All right. So I'm going to be recording a quick, crude video, basically to kind of report that I am kind of able to now solve sorting. So yeah, to kind of give a quick recap on that. So this is a slightly easier version of the problem that I've been talking about before in my videos, but basically, yeah, the problem is that you get a array of, I guess, potentially infinite size, and at any time you only see one square and you get no other information. So you start from absolute scratch. And from this, you have three different things that you can do, left, right, and swap, which you don't necessarily even know what to do yet, because the problem solver is giving no information. And from this, basically, you have to uh, figure out what information to keep track of, figure out what to do, figure out what to try to get more information, and basically ultimately build a sorting algorithm. So yeah, so this is a slightly easier problem than I've been talking about in my other videos, but still it has kind of this key characteristic, which is that the local optima is to do nothing, because there's actually a good chance that uh, the array just comes pre-sorted. It depends on the length, which I kind of have randomized. I have the array length randomized from 0 to infinite, and so yeah, there's a good chance that doing nothing is best, and so kind of you have to basically figure out a way to overcome this local optima, which you do through like exploration and stuff, all that type of stuff that I've been talking about. But yeah, this uh, won't get into that. Really, this is just to kind of show that um, this approach is kind of working. Um, yeah, so basically, through exploration, you can basically start to figure out like strategy, like different paths, and from then you can start doing abstraction. So basically, each of these small like trees or roots, whatever you want to call them, actually is an abstraction of a compound action that you can take. So basically, yeah, um, I've been running uh, basically my code, and it's created a bunch of these, and it can now solve sorting. So yeah, so basically, it was able to go from this into this. It doesn't it doesn't succeed always because I don't quite have loops working just yet, and also this thing can go infinite, or like the problem size can go infinite, and uh, with certain probability, and at that point, like you'll hit cases that the problem solver has never seen before, and or you'll hit problems that are so deep that like practically the problem solver will never get to, and so it won't quite solve stuff that's too infinite. But yeah, like stuff like this, it can sort. Um, and yeah, it has to keep track of basically all this state that you see is basically it tracking what it sees, so it can carry that information forward. So like if it sees this three, it needs to save that information as it basically continues to kind of manipulate the array until it gets the final answer correct. Um, yeah, so this is basically this is I got this from running my code for on like 5 threads for a few hours. So it's there's still a lot of optimization to do. Not to mention that like a lot of theory part stuff isn't quite correct. I still don't have loops working exactly as I want them to, and also the branching stuff could use some work. But basically, long story short, is just want to give kind of an update that um, yeah, the overall approach is working. Like it can create actions, and these actions encapsulate. It's not just a single branch. It includes decision making, right? So when you're including this action, it's not just one thing you do, but you include like this kind of this uh, a bunch of decision making that enables you to choose between multiple options, and but that's all of this is encapsulated into one scope, into one compound action that you can use. So um, yeah, so really this is just demonstrating that basically if you keep on creating branches, abstracting them, and then using these again and again, you can basically solve something like sorting. So um, yeah, that's it for now, and yeah, just kind of want to give an update on this. So